Hi, my name's Rich Williams, and I was the project parts engineer on the Lunar Reconnaissance Orbiter project. And what that means is I work with the designers starting early on in the project in selecting electronic parts and selecting parts that will work reliably during space applications. So that means everything from selecting them to handling the procurement to handling the testing to handling any issues that come up during integration and test all the way up until launch. Back in 2008, we had discovered that two large spacecraft vendors had intermittent and open circuit failures on two of their spacecraft just prior to delivery of the spacecraft. The investigation into this showed that the problem occurred on some socket contacts, G08S1 socket contacts, which are procured to a S311 specification that is written by Goddard Space Flight Center. These socket contacts are used very widespread here at Goddard. They're used on pretty much every spacecraft and instrument that we build, and this became a big issue and a big concern for us. These sockets were also being used on the LRO project. We procured about 29,000 to be used in many different areas, from engineering units to ground support equipment to harnessing to spaceflight. So we had approximately 1,600 being used on the spacecraft itself. So we had a concern if we were going to be impacted by a weaker intermittent or open circuit failure on orbit. Hi, my name's Rich Williams, and I was the project parts engineer on the Lunar Reconnaissance Orbiter project. The failure occurred on a G08S1 socket contact. This is procured to a Goddard specification S311P4. This is a specification that was written back in the early 90s and had not been modified in at least 10 years. So this is a contact, as I mentioned, is being used widespread throughout Goddard on pretty much every spacecraft that we build, and we really have not had any issues with these contacts. It's proven to be very robust, and we were very confident with it. So it was something that we never expected to have a failure with this particular socket. When we started hearing of these problems that were occurring at other spacecraft vendors, and eventually a guide-up problem advisory was written by one of the manufacturers, Tycho Electronics, that reported a reverse annealing problem, which is heat treating the wrong end of the socket during manufacturing. It's making the socket end of the contact soft and keeping the crimp side hard, which we actually want the reverse of that. We want to soften the material on the crimp side so that it does not crack during the crimping of the wire, and we want to keep the socket side nice and springy by not heat treating it. So as we identified this problem or heard about this problem, we started looking into this a little bit ourselves to see if we're impacted by it. We were working with this other spacecraft vendor, along with other people within the industry, trying to understand the problem. And as we started looking into it, this spacecraft vendor did a number of tests on some failed contacts that they had themselves. When they tested them, it revealed that the majority of the contacts that they had were not reverse annealed. They were actually heat treated properly. They were, in fact, there was another cause of the problem, and that problem was occurred during the manufacturing process, and it's an overboring of the socket end of the contact. And what that is as they're making the contact, they first drill the hole in the piece of material. Then they will come in and they'll slice a a slot down the middle of it, basically making two crescent moons if you were looking on end at this contact. And then to remove any burrs that are still there during the slicing process or the sawing process, they will come in with a drill bit, and they'll just run the drill bit through to remove any sharp edges or any burrs that remain. Well, they can use multiple drill bits during this process, and one drill bit in particular that they're using was shaped a lot like a paddle. It was basically flat, and as they would put that into the socket and they would be spinning it to remove the burrs, what would happen is as it would hit those slots that we just cut into the socket, or the manufacturer just cut into the socket, it would cause the drill bit to wobble. As it wobbled, it bored out the end of the socket or the well of the socket, and by doing so, it reduced the spring force on the socket tines. And that indeed ended up being the larger problem of the ones we've discovered. So as we discovered this, we said, how bad of a problem is that here at Goddard? And here at Goddard, we started looking at every board, every spacecraft, every instrument we're building, finding out how many sockets we're using, what are the lots that they're from, what manufacturers are they from, and started pulling all this inventory and basically quarantining it. And we took that inventory and started doing our own investigations by testing pin retention forces to see if we had any problems here. Fortunately, on the LRO project, by pulling all these residual inventories, we tested all of them, and all of them passed. That not only did they pass, but they passed with plenty of margin. We weren't showing any weak contacts. That gave us a measure of confidence, even though it was a small sample size. It gave us confidence that we may not have as high of a risk on LRO as we expected. But we took it a step further, and we said, we believe we're okay with this, but let's look at it a little farther. Let's look at the way that we're doing integration and test. What can we do different than what the spacecraft vendors that have experienced these failures, what can we do different than them to see if we may potentially be having symptoms of a bad socket contact? So what we did is we talked to all the test conductors during integration and test, talked to LRO management, and they were very supportive of doing this, and gave instruction to all the test conductors to think if an anomaly or a failure were to occur while they're doing testing, to consider could it possibly have been caused by an intermittent or open circuit failure from a contact. And whatever anomalies may have occurred during integration and test, that process was considered, and there were no instances where we believed that we had an intermittent or bad contact. Another problem that we discovered as we were doing this investigation is that during the manufacturing process, or prior to the manufacturers delivering the contacts, they're supposed to perform a pin retention test. We discovered that in many cases they were not doing the pin retention test, or they were not doing it properly. What they're supposed to do is they're supposed to take an oversized pin, mate it with a socket multiple times, and that's called a preconditioning step. After they do the preconditioning step, then they are supposed to mate with an undersized pin, or a minimum size pin, which is 29 mils, and make sure that contact can pass at least a 20-gram force. We found out that many of them were not doing that. If in fact they would have been doing that test, the problems that have occurred through overboring of the tines, or occurred due to the reverse annealing, they would have most likely have been caught if this additional test that was supposed to be performed was actually done. Since then, I can tell you the manufacturers have all instituted this, and they are all very cognizant of this potential failure. Within our group here at Goddard, as we were going through testing all of the residual inventory that we had quarantined, we started doing pin retention testing ourselves. We've done it. First, we did it through a kind of a unique way, taking what's actually a wire bond pull tester, and rigging it up to be to pull a socket or a pin out of a socket. And what it actually will do is it'll measure the force required to extract that pin at multiple steps during the process. And what this did that was very nice was it allowed us to measure the forces and basically chart all of them and find out, do we have within a particular lot, are they all around the same 100-gram force, which is about what we were measuring, or are they scattered throughout and kind of random? We plotted this for multiple manufacturers. For Tyco Electronics, we use the lion's share of contacts that we use here at Goddard are procured by Tyco Electronics, or procured from Tyco Electronics. And then the next biggest company we use is called Positronic. And then the third, much less used, is ITT Cannon. So we tested contacts from all three of these vendors. And again, we're testing this from contacts we had in residual inventory. And to our surprise, even though we initially thought this problem was just a Tyco problem, we come to find out that Tyco actually, at least from the inventory we had, performed best of all three companies. The distribution of forces for all of the samples that we tested for Tyco were, with few exceptions, were tightly bound, around 100-gram force. For Positronic and for ITT Cannon, if you looked at the graphs of all the samples that are tested, they were much more random, and they would measure anywhere from 20-gram force all the way up to 100-gram force, and they're scattered all throughout. But the majority of them were above 40 grams at least. So this was a great test for us to do and to understand this problem. Unfortunately, it's a very slow process to do, and if you have each spacecraft using several thousand, and then you want to make sure the contacts you're using in your engineering units and your ground support equipment is good too, so you're probably using 5,000 or more of these on a typical spacecraft just in all these different places and hardware. You can't expect that you're going to be able to test those quickly in this manner. So one of the engineers within our group came up with a unique way of doing the test very quickly. What he did is he took a 29 mil pin and had it mounted in a 40-gram weight, and you'll see pictures of that. And then he also took a 30 mil pin, which is the max diameter that can mate to a socket, to a G08 S1 socket. And what we were able to do is just do multiple mate demates with the oversized 30 mil pin, and then just take that socket, mate it to the socket that's on the 40-gram weight, and if you can pick it up and it's not sliding, then we know that the weight is that the force of the socket, the pin retention force, is at least 40 grams. By that, we know that that's at least a good socket. We didn't care, how high it measured. We knew it would be reliable for our application. The specification actually calls for a 20-gram force as passing, so anything above 20 grams is acceptable. You'd ask, well, why did we test at 40 grams? Well, we didn't want a socket that just barely passed the requirement to be used in spaceflight hardware and then potentially have an issue later on. We wanted to add some margin to that. And plus we knew that if a socket was measuring at 20 grams, it was going to be an outlier anyway from the typical population of sockets, and was going to be something was not right with that socket. So we set the bar a little bit higher. We set it at 40 grams, and we use what we call our go, no-go test, using this 40-gram weight the preconditioning step, and then can we pick up that weight with the sockets. And that's a much faster test than actually having to test up or set up a tester for each lot of parts that we're going to run. So that's what we did, and we've done that for thousands and thousands of contacts for every project here on Center. At the beginning, when we discovered this problem and we knew that we had a big issue, but we didn't know how big it was, we wanted to make sure that we were safe. And the only way that we could be safe was to test every socket that we had. Because we've now indicted basically every socket manufacturer that we have, we had no choice but to test all the material that we're getting from each one of them. So whether the company had all their sockets measuring perfectly, or whether they had some that was some randomness in the measurement, as long as we could test them and prove that they were going to be acceptable, that was going to be good enough for us, at least at this particular time. So we did go through the painful process, and you can imagine the poor person that was doing this test. It is a lot of work to do this. Since then, we've been able to back off on that a little bit. As we've started knowing which manufacturers are more reliable and which ones are less reliable, we try to steer the procurement towards the more reliable companies. And then we will do a sample test. I don't recall the sample sizes, but if you had a 10,000 piece procurement from a particular manufacturer, instead of testing all 10,000, we're going to tell you to test a smaller sample of that. And if you test all of them and they all measure within family, passing the requirement, in flying colors, then we will not force you to do the testing of the remainder of the lot. Hi, my name's Rich Williams, and I was the project parts engineer on the Lunar Reconnaissance Orbiter project. As we started going through this investigation, we had to send a team of engineers to first to Tyco and then to the other manufacturers of the socket contacts to investigate their process. We were trying to understand what was going wrong here. Initially, as this problem came up, prior to us getting involved, this large spacecraft vendor had been working with Tyco to try to figure out what caused this problem. So they had already identified between the spacecraft vendor and Tyco that the problem was a reverse annealing. Tyco had at that point agreed to put out a guide up problem advisory, which goes out to the entire spacecraft and military community, saying we've had a problem with this particular part. Here's what the problem is, and then on top, or as a part of that, they will say this is what we've done about the problem to fix it. So at this point they were admitting that they had a potential reverse annealing problem. They at that point were saying it's a very small problem, maybe one in every 250,000 contacts that we make may have this problem. Well, as these spacecraft vendors that have had these failures started testing their inventory, we started finding out that, now the failure rate was more like 1 in every 4,000, at least from the lots that they had. And that inspection was actually just a visual inspection they were doing at that point. And this is the spacecraft vendor. They were just doing a visual inspection to see if they can see the tines within the socket. And so we thought, okay, the failure rate's more like 1 in every 4,000. Well, as we started, went a little further and said, pin retention testing is actually the better measurement of if it's reliable or not. When these spacecraft vendors started testing their inventory, they found out, no, their failure rate now dropped from 1 in every 4,000 to somewhere in the neighborhood of 1 in every 100 or 1 in every 200. So the problem was was much more than what we expected. But the guide up that was written by Tyco makes the rest of the community think that it's not a big problem. We knew it was much more than that. Since we knew that, we sent our team of engineers to Tyco first and found out something interesting. Tyco was originally a company called AMP Incorporated in Pennsylvania. It was a smaller company, built very good product. Tyco's a very large company that bought them out. When they bought AMP, we had assumed that all the manufacturing was still being done in Pennsylvania. Come to find out, when this problem came out, that they actually moved their manufacturing to a small machine shop in Switzerland. And we had never been to that company, so we didn't know anything about it, whether it was good or bad. So that was the first place we sent our team of engineers. They went, they met with the company. They were very impressed with the company, which is a good thing. They did have their act together, but there were some things that we found out. They actually did not know of these other issues. They did not. They admitted to the reverse annealing, and they also admitted to the not doing the testing right, the preconditioning step and the pin retention testing. They admitted to that. They had never heard anything about the overboring of the tines. That was something new to them. So when that was brought up to them, they had to look a little further into it. And after looking at it, they're the ones that came up with the rationale for how it was possibly being caused by a particular drill bit. So that was the company we went to. It was good for us to be able to see this company, but it was also good for them because we were able to help them in making their process and their contacts better. While we were doing that, we said, let's go to the other companies. We went to Positronic Industries, which is in Missouri. When we went to Positronic, started finding that they had very similar issues to Tyco. And when we're finding out that they have similar issues, and then we've done some of our pin retention testing, and we know that the pin retention force measured was not as tightly bound as what we had seen from Tyco. We knew that there were some issues there. We started discover that they too could have issues with reverse annealing, could have issues with pin retention testing, could have issues with overboring, and in fact they did. And then the third company is ITT Cannon. We visited them, had less dialogue with that company, since that is one that we don't deal with as much, and there's very few contacts bought from them. We didn't spend much time discussing all this with them. But as we found out this information, we started asking other questions of, if this is not as robust of a contact as we thought it was, is there something better out there? And we've asked that question to Positronic. They actually have a contact that they believe is much more robust. They were selling the G08S1 contact to us because that's what we were asking for. But now that we're coming to them saying, do you have something that would work better, then they've brought up another option. We also went to another company called Hypertronics, who does not make the G08S1, but makes a very robust style contact. Went to them and said, are you interested? We're looking for alternatives out there, anything. And they came out, they have a contact called their Hypertac contact. They said we could easily convert that into one that would work in your connectors. So they're working on coming up with another option. Tyco came up with a different option that they threw out to us as well. And the good part about all of this is, although we've had this issue with the G08 socket, it's pushing us to finding a more robust socket contact for the future. And we're very close to doing that. We're actually not just picking one company and saying we're just going with your one socket design. We're picking multiple different designs from different companies to allow everybody to have to be able to supply to us. So our specification, that S311P4 specification, is being modified. We're having additions of socket contacts added to that are going to be available from from different vendors, and they're going to have different designs. So that is actually in process and will be available very, very soon. Hi, my name's Rich Williams, and I was the project parts engineer on the Lunar Reconnaissance Orbiter project. What I have in my hand here is a G08 S1 socket. This is the part that we've been talking about. As you can see, it's very small. We have two sides to it. The smaller side on this end is for crimp connections. You'd slide a wire into the end, and you'd pinch it down until it can't pull out. On the other side is the socket mating end. You'll actually have a pin that will look similar to this that would actually mate into the socket, like that. Over top of the socket tines that are actually attaching to the pin is a metal shroud. That's why you can't see the slotted contact that I described in my presentation. This socket will actually be mounted in what's called a D-sub connector, and that is what I'm holding in my hand here. The sockets, after being crimped to a wire, would actually be put in this end and shoved all the way in until they snap in place, and now they become part of this connector. The connectors, once populated with contacts, are then mated with the pins which are in this connector, and then you would place them together and they'd snap shut. I'd like to demonstrate for you the go no-go testing that we came up with within our lab. What that entails is the G08 S1 socket that we have here. You would take an oversized pin, a 30 mil diameter pin, which I have in my hand, and you would do multiple mating steps. So you just mate and do that multiple times with the socket, and what that's doing is that's spreading the socket tines apart, and then they have to come back together. You're doing that multiple times. That will help if you had a weak contact, if you had one that was weakened by reverse annealing or the overboring that was described. That would actually press them apart, and they would want to stay apart. After that, you would take this socket, and then you would just mate it to the top of this pin, which is a 29 mil diameter pin attached to a 40-gram weight, and pick it up. If you can pick it up and hold it without it sliding out, then you know that the mating force or the pin retention force of this socket contact is at least 40 grams. Hi, my name's Rich Williams, and I was the project parts engineer on the Lunar Reconnaissance Orbiter project. Some lessons that we've learned out of this, one very important one is just because a part has been reliable and something that we've used for a very long time here doesn't necessarily mean that it doesn't have a inherent flaw within it, and don't just accept that part the way it is. The parts engineering community needs to be very involved in every part, whether it's a heritage part that we've used forever or whether it's a brand new part that's being used for the very first time. Quality engineering needs to be very involved in visiting the manufacturers and making sure that we understand the process that's going through in the making of these parts. We need to make sure that there's nothing that is there that could potentially be a major problem that we've allowed into flight hardware just because we assumed it was going to be safe. Another very important lesson that we learned out of this is don't accept the obvious answer. In the example of the guide up problem advisory that was issued by Tyco Electronics, they said that the problem was caused by reverse annealing. Everybody wanted to believe that was the only problem that was caused by this or that was there. They also said that the failure rate was only 1 in every 250,000 or somewhere in that neighborhood, and that too was makes you feel more comfortable that you probably don't have a problem. But we didn't want to just believe that. We wanted to have proof that indeed that was the problem. That information was correct. So we dug deeper. Here at the Goddard Space Flight Center, we started doing our own testing. The other spacecraft vendors affected by this, they were testing their inventory and finding out what the problem is. And because of doing that and doing your engineering due diligence and understanding the problem, it uncovered the other two issues: the fact that the parts weren't being screened properly before they left the manufacturer, the overboring of the tines, which ended up being the more major cause of most of the failures than the reverse annealing. Because of looking at that, we realized the failure rate could in fact be much higher, and because of that, we were able to understand the problem much better and know what we needed to do to be able to test to make sure that we weren't impacted by this. Another very important note to make is that we discovered that initially this was a Tyco problem. They were the ones that were indicted as putting out a bad product. And as we looked into this further, we realized that this was more of a systemic problem that was not only impacting Tyco, but was impacting every manufacturer of G08S1 sockets that were being supplied. It was something that was inherent to the way that the parts were being made and being tested, and there was no one company out there that was the cause of the problem. It was something that everybody was impacted by.